Can you introduce yourself?
My name is Arghya and I have completed my MSc from Jadavpur University and I am working as a scientific assistant in National Test House.
At the where? You said?
National Test House.
Uh, Arghya, what is the meaning of your name?
In Bengali, it means the elements of a puja. मतलब means जो the components that are required in a puja.
Okay, so why do you wish to join GSI? As you are already working somewhere, why do you wish to join GSI?
Because I like the subject geophysics and I am working at a group B level, so I want to get a higher post and GSI will give much exposure and better opportunity to serve the country.
Okay, what is your actual job profile at the place you are working?
It is a laboratory actually, so we have to conduct tests on samples according to Indian standards.
Okay, what kind of samples you are using?
No, we don't use any samples. We manufacturers provide us samples. They need certificates that their sample comply with Indian standards or not from a government organization. So we test them and give them certificates.
Okay, okay, okay. Okay, what are your hobbies?
My hobbies watching movies mainly.
Can you repeat?
Watching movies.
Okay, which movie did you watch last?
Last I watched a web series actually. I watched House of the Dragon.
Okay, who was the director of the movie?
That I don't know.
Okay. Has this movie won any of the prizes?
I don't think so. It has been just released.
Okay, fine. So, what is geophysics, Arghya?
Geophysics. Geophysics is actually the interaction of geology and physics in which different physical methods are used to interpret the subsurface phenomena.
What kind of different phenomena you are talking about?
I mean, to analyze the subsurface properties uh, by doing survey and analyzing the data by physical methods.
Okay, do you know any of the physical methods?
There are lots of methods like gravity,
Right.
seismic, magnetic, electromagnetic, electrical, etc.
Okay. So, how many types of electromagnetic methods do you know?
Uh, there are continuous wave electromagnetic method in which there are also different types of like tilt angle method, very low frequency method, audio frequency method, horizontal loop method, etc. And there is time domain electromagnetic method. There is magnetotelluric method, etc.
Okay. Can you classify them as active and passive methods?
Uh, every method is active except the magnetotelluric one.
Okay. You told one as a very low frequency method, right?
Yes.
What is it?
Uh, this is a type of tilt angle method. It is called very low frequency method.
Can you tell me the range of how much low frequency it is using?
It is using in the range of kilohertz, 1 to 10 kilohertz.
Do you think is it suitable to call it very low? क्योंकि हम तो 0.001 hertz को भी low कह सकते हैं. Why are we saying 1 kilohertz as very low frequency?
It is actually a nomenclature. 0.001 को शायद हम extremely low frequency कहते हैं, ELF. और
ऐसा कोई मेथड है?
ऐसा मेथड तो है, मतलब ऑडियो फ्रीक्वेंसी मेथड है, जिस इन द ऑडियो फ्रीक्वेंसी मेथड वी यूज close to 1 hertz to 1000 also. Range is 1 to 1000 hertz, and below that I don't think we are this is used in electromagnetic method.
Okay. What is auto frequency? F-mag method?
In this method we use the natural electromagnetic field generated by thunderstorm as the source. Okay, okay, it's also in the question previously you asked, it is also a passive method. We don't use any active source. Okay, and in this case we measure the tilt angle by orthogonal two orthogonal coils mm, which are kept at an angle of 45 degrees. So when there is a anomalous body in subsurface, there will be a output, non-zero output.
Okay. You use it on tilt angle. What is it?
Tilt angle actually the primary magnetic field generates a secondary magnetic field at the receiver through the eddy current generated in the conductor. So this the resultant of the primary field and secondary field makes an angle theta with the primary field, and this theta is measured by this method. Uh, actually, as a receiver, coil is used, and by rotating the coil, a certain orientation is achieved when there is uh, highest signal. So this is the angle at which the conductor lies. Uh, this is basically the tilt angle method.
Okay. What are eddy currents?
Eddy currents are when there is a alternating magnetic field, in presence of alternating magnetic field in a conductor, by electromagnetic induction a current is generated. A current is generated according to Faraday's law, and this current is actually curly, loopy. I mean, it flows in loops, and eddy means actually loop or like that. So these are called eddy currents.
What is Faraday's law?
Faraday's law actually changing magnetic field produces electric field.
Okay. Which Maxwell's relation tells us about the Faraday's law?
Maxwell's third relation, curl of electric field equal to minus del B del T, where B is the magnetic field.
Okay. What is the significance of curl of any vector quantity?
Curl means it is a rotation of that vector.
Okay. And if it is zero, then?
There is no rotation. It is called irrotational, I think.
Uh, can you tell me the basic principle behind GPR technique?
In GPR technique, very high frequency radar signal is used in the range of radio wave range megahertz to gigahertz, and in this range, the fourth Maxwell's equation, the second term becomes more pronounced, and the first term, as the second term is proportional to the square of the frequency. So by deleting the first term, we obtain the electromagnetic wave equation. So in this case, the radar wave behaves like electromagnetic wave, and so it follows the rules of reflection, refraction, etc. So a short radar pulse is generated from a transmitter above the subsurface, and a reflector is kept just beside. So we receive near vertical reflection from shallow subsurface inhomogeneities, and like seismic reflection, it can also map the subsurface structures at a very low depth.
Okay. Okay. Is there any difference between GPR and radar?
There is no such difference. GPR is used in ground survey, but actually the principle is same as of radar and GPR.
What is the depth of penetration for GPR?
About 20 to 30 meter normally, but also 100 meter to 500 meter can be achieved.
Okay. Any practical applications of GPR?
In GPR, in geotechnical surveys, we can measure the depth to bedrock. Also, we can near surface inhomogeneities. Also, these are used in geotechnical survey. Or also, we can. It is also sometimes used in groundwater exploration. Also,
But can we achieve मतलब GPR is approximately 20 to 30 meters, right? So can we
yes.
achieve groundwater from this?
We cannot achieve from 20 to 30 meter, but sometimes it can be applied in greater depth up to 400 500 meter. Also by
But
because the
won't it be
radio
so
wave.
cost?
What?
Won't it be so costly?
Why?
हाँ,
I
is
don't know.
costly नहीं होगा अगर हम मतलब उसका डेप्थ ऑफ पेनिट्रेशन अप्रोक्सीमेटली 20 to 30 मीटर है राइट.
Yes,
बट हम किसी सिचुएशन में 100 to 500 मीटर तक जा सकते हैं
yes,
एज पर यू आर सेइंग राइट.
yes.
तो अगर हम 100 to 500 मीटर तक जाएंगे तो क्या ये हमें बहुत कॉस्टली नहीं पड़ेगा?
I don't know about the cost. I just know that if you apply more low frequency, I mean depth is inversely proportional to the frequency. If we can apply lower frequency, we can achieve greater depth.
Okay, तो कोई और ऐसा मेथड है जो हम ग्राउंड वाटर के लिए यूज कर सके?
Yes, we can use resistivity method.
Okay, and what are geotechnical surveys that you were talking about?
Geotechnical surveys actually those are related with uh, civil engineering in which the I mean the engineering properties of rocks are studied.
And what are the engineering properties of rocks?
Engineering properties of rocks like resistivity that we measure by or conductivity or
These are the normal properties.
those are application in engineering. I mean by engineering properties I think those are applicated in engineering field. I mean,
Okay. Okay, thank you. I'm done.
thank you.
Thank you, Arthur. Sanu?
Okay. Okay. Arghya, your hobbies is watching movie now.
Yes,
So which type of movie you like to watch?
a lot varying types of movies. from ranging from Hollywood to Bollywood to
Means you like any type, means it is comedy, drama, or detective type, or you don't have any such classification.
I don't have any such choice. I watch every movie that is good, let it be comedy or drama or suspense.
Okay, good. And do you know that the means award given in movie? Can you name few award which are most prestigious?
Okay, in Hollywood there are Oscars, Emmys, Golden Globe, and in Bollywood there is Filmfare, IFA,
Okay. And from government of India side, there is given a one award also.
a national award.
Yes. Okay. Another thing that the whatever you mentioned in Daphna, so means there is three or four column is there, na? So means you are got any prize or not, or another thing that is your achievement in sports. So do you feel anything in this?
Please repeat, 3 or 4 columns for.
Means there is option na extracurricular activity, they you are won any prize or your sports leadership.
No, no, I have not filled because I am not such at sports.
Okay, okay, no problem. I am just asking that if you feel, then I will ask you question about it. Okay, no problem.
No,
Okay. So next thing that the I think why we are using the EM survey,
why we
means we are got it from resistivity survey now. Why we are using EM?
uh, the one advantage of EM survey over resistivity survey is that we don't need any contact with ground, so the cost is less,
Okay,
and that the time is also less because we don't have to arrange those electrodes, and we
but
just
all time we are not touching ground. If
no
we
no
touch
we
ground,
can we yes, but there are also provisions that we can measure without uh, touching ground.
okay. As a light is a electromagnetic wave,
Yes.
so can we use a light source for electromagnetic survey?
um, no, the frequency of, I mean, the okay, I think the frequency cannot be applicable, cannot be the frequency of visible light. You are talking about visible light, I think so.
Yes, yes. Okay,
And also the I don't, also I think we need alternating magnetic field. Is I don't
so
think
what is difference between light, electromagnetic wave, and not whatever you are using electromagnetic wave? Can you know any difference?
uh, I think the main difference is the we need the alternating magnetic field. That is, if we use simple light, we cannot achieve that. That alternating magnetic field will generate the eddy current in the conductor, and also
So light don't have visible light don't have alternating magnetic field.
okay. Yes, yes, but I think the frequency is the main point. The frequency of visible light is not suitable for this type of application.
Okay. Okay, tell me about that all the electromagnetic method we are using and means what physical parameter we are measuring.
As a physical parameter, we're measuring the conductivity, and the methods are tilt angle method, very low frequency method, audio frequency electromagnetic method, time domain electromagnetic method, horizontal loop electromagnetic method, magnetotelluric method.
Okay, and what is horizontal magnetic method?
What is?
You, you said na that horizontal electromagnetic method. So what it is?
In the horizontal magnetic method, we have two coils. One is transmitter and another is receiver, and those are connected with a cable, and we supply a primary magnetic field from the transmitter that generates eddy current in the conductor, if there is any conductor, and the secondary signal generated by the eddy current is sensed by the receiver, and the phase difference between the primary and secondary field is measured, the real part and the imaginary part, and those are plotted with distance. We move the transmitter and receiver over a suspected anomalous source, and uh, near to the anomalous source there will be a anomaly in the curve. So thus we can obtain the location of the conductor and the conductivity of the place.
Okay, okay. Which property we are measuring in GPR method?
We are measuring the dielectric constant or permittivity.
Okay, why we are measuring? Means how we are measuring in dielectric constant.
Actually, we send a radar signal that is in the microwave range. The frequency of the signal is the microwave range, and in this range, the signal behaves like a electromagnetic. The signal, the velocity of the signal is like dependent on the dielectric constant of the material, and so by by catching the reflected signal, we can measure the travel time, and from that we can obtain the velocity.
Okay. I think that you said now that GPR and radar both are, have similar.
Yes.
So can you different? You know any difference?
No,
Or otherwise we can say that GPR is radar.
yes, GPR is a type of radar.
Type of
It
radar,
is.
but it's completely means no difference.
I don't know of any difference because it is a type of radar. It is used in ground penetration. That is, it is called ground penetrating radar.
Okay, means
If you know, please tell.
okay means it is difference in frequency. I'm asking. Means GPR we are using that very high frequency, na?
Yes, in
And
radar
radar
frequency.
we are using a radio.
Yes, in GPR we also use the radio frequency. The radio frequency has a very high range from megahertz to gigahertz. We can this all comes into radio frequency range.
GPR also use radio frequency.
Yes.
Okay, I have to check it. Means,
So you think what type
okay.
of frequency?
Mm, I, mm, means I thought it's just given in the very high frequency. I thought that it's maybe radio wave. We are considering it low frequency wave now.
No, actually, in radio wave or microwave, that is same as radio wave. It's a long frequency range
Like the very low frequency range,
from
which type of
megahertz to gigahertz,
frequency?
not hertz, not in the hertz level.
No,
That
no.
is
In PLF method, what is the frequency range?
in VLF. That is in kilohertz, 10 to 20 kilohertz.
Also megahertz also.
In VLF,
Okay, I'm telling you that PLF what is given in book.
uh,
So and VLF we are using VLF. It is the radio frequency. So no, PLF it is given in kilohertz. Yes, it's kilohertz. So it is given 15 to 25 kilohertz,
yes, yes.
and it is in the radio frequency range. And GPR it is given. GPR it is given in megahertz. So megahertz also come in radio wave now.
Yes,
Insane.
yes, yes.
Okay, I will check it. Okay. So what? Okay, leave. I will, another thing that what is the penetration depth?
Okay, the penetration depth is the maximum depth up to which the electromagnetic wave can penetrate the ground.
Okay. And which factor it is depending on?
It is depending on the conductivity of the ground and the frequency of the applied wave.
Okay. Only these two quantity is depending.
Okay, and also the also the permeability of the rocks.
Yes. So can you tell me that which Ampere law we are using most in the electromagnetic side? Sorry, which Maxwell law?
We mostly use the fourth Maxwell's fourth law, and third law is also used in principle, but those two are used.
So if we want to describe electromagnetic wave, so we need only two law, or we need all four law.
To describe an electromagnetic wave,
Yes.
okay, by with these two laws, I think we can describe electromagnetic wave. But other two laws are also inherent. I mean, we need them also. Those are very basic. We cannot use anything without them.
So like Maxwell equation, we are derived the wave equation.
So deriving wave equation, we need only those two laws.
Only those two laws. We don't know first, second.
Okay, I forgot the derivation actually. Uh,
Okay. Another thing that do you know that the transverse electric mode and transverse magnetic mode?
okay, in transverse electric mode, the electric field is transverse to the direction of propagation, uh, and in transverse magnetic mode, the magnetic field is transverse to the direction of propagation. I mean, there is no component of electric field parallel to the direction of propagation.
Okay. And we can use this wave in electromagnetic survey. And which type we are using mostly?
I don't know actually.
Okay. next is that. Can you tell me a few limitations about the electromagnetic wave?
Few limitation of
Electromagnetic wave, electromagnetic method.
uh, uh, okay. We can obtain anomaly from uh, non-economic sources also. Like we actually use the electromagnetic method for economic sources like minerals, but useful minerals. But from other sources, we can also obtain the anomaly, and the penetration depth is not great.
Okay. So penetration depth is not so high. This is
Yes,
limitation.
yes.
And the, which method we are using for high penetration?
Magnetotelluric method, we have high penetration. I just told about the other methods. Magnetotelluric, we have the highest penetration.
So it is considering EM or
It's obviously it's EM method. I don't know any other drawbacks.
okay. So what is the? Can you tell me the difference between that telluric and magnetotelluric?
The field is called magnetotelluric, and the current the field generates, that is called the telluric current. We are saying about the method, difference of method.
No, 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 it's okay. Can you tell me that what different method are you using to measure?
Okay, in telluric method, the telluric currents flows in horizontal loops below the subsurface, and we measure the potential difference at any 2 point by non-polarizing electrode, and we obtain about the potential gradient is about uh, millivolt, in the millivolt range. And by telluric method uh, we can detect anticlinal structure that is useful in oil exploration. And in magnetotelluric method, we measure the magnetic field and electric field components. By magnetometer, we measure the magnetic field components, and uh, we measure
Okay, tell me another. Okay, tell me another thing. That the telluric current we can utilize it in our application generation electricity or anything.
please repeat, I didn't get.
So telluric current, if we are using the telluric current, it can be used in our daily application generation of electricity. You got my question or not?
Yeah, I get your question.
Any idea?
No idea.
Okay. Okay. Thank you again.
Thank you.
I think Gauri.
Am I audible?
Yes.
Can you name the four Maxwell equations?
Uh, fast, fast Maxwell equations is uh, divergence of electric field equal to rho by epsilon naught. It is actually the Gauss's law of electricity, and the second one is the Ampere's law, divergence of magnetic field equal to zero. And the third one is Faraday's law, curl of electric field equal to minus del B del T. And the fourth one is Maxwell's law, curl of magnetic field equal to mu 0 J plus mu 0 epsilon 0 del E del T.
Okay. So what does this Gauss law means?
The Gauss law means that the flux of any electric field through a closed surface is equal to 1 by epsilon naught into charge enclosed in that surface.
So what conclusion uh,
Your voice is not audible.
you get from this about this mm magnetic force? Did you arrive from this Gauss law?
Repeat the question, I could
Hello?
not get.
What conclusion? Hello, am I
Yes,
audible?
yes, now audible.
Okay. What conclusion do you get about the nature of the existence of magnetic poles from this Gauss's law?
From the first law, we don't get any conclusion. From the second law, that divergence of magnetic field is equal to zero. That is actually a form of Ampere's law. Hello, hello.
So what is the nature of magnetic force?
The nature of magnetic force
Poles,
poles.
poles.
The nature is that monopole does not exist. Only dipole exist.
How can you substantiate that? Why? How can you relate that with this Gauss law?
We relate it with the second law, the divergence of magnetic field equal to zero.
What I mean is how? Why you? Why this magnetic flux enclosed within this is becoming zero? That's what I'm.
I
Gauri,
don't
can
know
you
the
please
reason.
repeat your question?
Is my voice breaking?
Yes.
I have some network issue.
Hello, Gori. Your voice is not audible.
I mean that how this existence of and
I actually it is experimentally obtained that the magnetic flux through any closed surface is zero. I think I don't know any reason why this is obtained.
Okay, if you are given a charge,
Yes,
hello,
yes,
are you?
yes.
I think you are getting the voice message sometime after.
Okay, Aswadik can continue if Gauri has some problem in network.
That it's delayed. Okay, if you are given a charge, how can you generate electromagnetic wave with that? This is the question. Better.
We have to accelerate the charge. We have to accelerate the charge.
हेलो एवरीवन, क्या डिस्कशन चल रहा है?
मेरा इंटरव्यू चल रहा है इलेक्ट्रोमैग्नेटिक मेथड पे।
अच्छा अच्छा, ओके।
I think Gauri का कुछ disturbance हो रहा है, तो I think so Gauri is asking that Ashok, can you want to continue ask question or not?
Yes, Sanu. Hello.
Yes, so continue.
Am I audible?
Yes, yes.
Yes.
Yes, Arghya. Arghya, your general question interview has been done or not? Means questions from general area.
Okay,
Yeah.
I can repeat your all this hobby and all these things.
All these my hobby is to watch movies.
Okay. Which kind of movies do you like?
Every kind of movies ranging from classical Hollywood to latest Bollywood, everything.
Okay, good. So, can you tell me the first Indian movie? The name
No,
of the movie?
no, I don't.
Okay. So, can you name? Okay, who's your favorite one? Star.
Shah Rukh Khan.
Okay. So, can you name two movies?
Yeah, Chak De India, Dil Se.
Okay. So, what have you learned from these two movies? Can you tell us?
Okay. Uh, from Chak De India, I learned that you must continue to fight whatever the situation may be. Uh, if you are in a very bad situation, you can also overcome that by your fighting spirit. And
Okay, Agya, have you seen a symbol in the starting of every certified Indian movies? There is a symbol of the A plus, AB. Have you noticed?
no,
Okay.
you are talking about the rating A U by A.
Yes, yes, yes.
Yes, A for
So,
adult and U for underage.
okay. Is there any other category?
I don't know. I know only A, U or U by A.
Okay. So, okay, any sirf this only hobby? Just you like to watch the movies, yes? Or any other?
Yes, not anything else.
Okay. And at present, what are you doing?
At present, I am working as a scientific assistant at National Test House.
Okay. So, what is the role of National Test House?
National Test House is a multidisciplinary laboratory of Government of India, in which it is an NABL accredited laboratory. Uh, so different types of manufacturers produces their products, and all the products have to be complied with the Indian standards, and that is certified by National Test House.
Okay. So, this institute is under which department or
Ministry
which
of
ministry?
Consumer Affairs.
Okay. So, basically, it handles the data related to the consumer, huh?
No, it is under Consumer Affairs, but no such data of consumers. Just testing samples and giving certificates.
Okay. So, okay, you have already in the government job. So, why do you want to come this in this field?
Because geophysics is a fascinating subject, and it will give a much more exposure than where I am, and I can explore many new places, and I love the subject geophysics.
Okay. So, is there is a specific meaning of your name?
Yeah, my name means in Bengali, this means the elements of a puja.
Hey, great. Okay. Comes to the geophysics part. So, what do you what are we exploring using the geophysics?
We are exploring the subsurface of Earth.
So, what is inside the subsurface of Earth?
There are rocks, minerals, and other substances.
Okay. And
Mainly rocks.
why do we need the minerals?
We need the minerals in our day-to-day use in in uh, in chemical factories to produce the different products that we use.
Okay. So, what is the difference between the geophysical method and the geotechnical method?
Geotechnical method is related is a part of actually it's not a part. So geotechnical method is related to civil engineering. It is used in constructional purposes. We study the properties of rocks and subsurface that is only useful in constructions of buildings.
Okay. So, tell me the three advantage of the geophysical method over the geotechnical method.
Okay. By geophysical method, we can explore the hydrocarbon fields that we cannot do with geotechnical method. and we can explore groundwater resources that we cannot do with geotechnical method. Actually, the application of geotechnical method is very limited.
Okay. Now, okay. So, tell us the how many branches of geophysics do you know?
How many branches of geophysics? There is seismology, gravity method, electrical method, electromagnetic method, seismic method, and
And
borehole logging.
okay, so which one is your favorite,
I have no
or
such
you are
favorite.
most interested?
I am most interested in seismic.
Okay. Okay, today we will discuss about the electromagnetic method.
Yes.
Okay. So can you tell me the what is the EM spectrum? First, tell us the what are the EM waves?
The electromagnetic waves are a type of transverse waves generated by the perpendicular electrical field and magnetic field.
And what are the sources? How can we produce EM waves?
We can produce EM waves by accelerating charge, by oscillating dipole, by any alternating current moving through a wire like antenna or transmitter coil.
Okay, so these are the artificial sources, right?
Right.
Any natural source?
Natural source is the ionospheric current, ionospheric alternating current.
So that is the EM wave.
Yes, that is a type of EM wave.
Okay. So is the sunlight is also EM wave, EM radiation?
Yes.
So how it is different from other ranges of the other ranges which lies within the EM spectrum?
It is different in the frequency. It is the range of frequency is in micrometer point. In the wavelength range is in micrometer, point 0.4 to point 0.7 micrometer. And other electromagnetic waves have different range of wavelength.
Okay. So what is the speed of EM wave?
It is the speed of light, 3 into 10 to the power 8 meter per second.
Okay, so it is always constant in all medium, or will it change?
No, it can be changed.
How?
In a medium of dielectric constant uh, k, the the velocity will be c by root over k.
Okay. So are there any mathematical equations to deal with the electromagnetic waves?
There are four Maxwell's equations.
Okay. Tell us what are these four Maxwell equation?
Okay, the first one is del dot E is equal to rho by epsilon 0 in free space, del dot E equal to 0. And the second one is del dot B equal to 0. The third one is curl of E equal to minus del B del T. And the fourth one is curl of B equal to mu 0 J plus mu 0 epsilon 0 del E del T. And in matter, the form changes.
Okay. So in with respect to the fourth Maxwell equation, what is the significance of this?
The significance of fourth Maxwell's equations is that the changing electric field can produce magnetic field. Changing electric field and a certain current density both can produce magnetic field.
Okay. Okay. Is the displacement current real or virtual current?
Okay, we cannot measure the displacement current, so we can say it is a type of virtual current.
Okay. And what is the direction of this current? Can we predict the direction?
Direction of, I don't know about the direction.
Okay. So you have the fourth Maxwell equation in the vector form. So
Yeah.
from there, can you?
Okay, the direction of current is the direction of the electric field.
Okay. And static magnetic field produce.
Please repeat.
Can a static field produce the displacement current?
No, no, it is produced by the changing electric field.
Okay. Hello.
Yes.
Okay. Comes to the electromatic method. So how can we use EM method to explore a mineral?
In the EM method, we generate electromagnetic wave by a transmitter coil. That alternating magnetic field part induces eddy current if there is any conductor, and we use a receiver coil, and that eddy current generated in the conductor uh, generates its own secondary magnetic field in the receiver. So the receiver receives both the primary field and secondary field. By measuring the phase difference, we can calculate the conductivity of the anomalous body.
Okay. So you have used the conducting bodies basically interacting with the EM waves, right?
Yes, yes.
So how EM waves interact with a conductor? Can you tell us in brief?
Okay, in conductor, the electromagnetic wave penetrates up to a certain depth, and that is known as the skin depth, penetration depth. And actually we use the term skin depth for mathematical purpose. And the also it generates a eddy current in the conductor. According to Faraday's law, the changing magnetic field part of the EM wave generates a electric field or EMF or eddy current. So
Okay.
I think this is it.
So what are the eddy currents?
The eddy currents are a type of current loop that is generated in a conductor in the presence of alternating magnetic field. The term eddy means loop.
Suppose we have a circular conductor, right?
Circular conductor.
Yes. Means the conducting wire in the circular form.
Okay.
So can it be can it will be generated in it also?
Yes.
And what will be the direction?
The direction of eddy current. Okay, the current will be in such a direction that the magnetic field it produces will oppose the external magnetic field.
And what is the name of that law?
That is known as Lenz's law.
Oh, Lenz law. It is the. It is what? It is the statement of which, or
Actually,
any
Lenz's law gives us the direction of the induced current. It is a form of Faraday's law, which tells us that current will be induced, and Lenz's law gives the direction. Am I audible? My voice is echoing.
Yes, yes, yes. You are audible, Arghya. Okay, good. So, okay, so comes to the magnetotelluric method. So,
Okay.
what are the telluric currents?
Okay. In ionosphere, there are certain ions or molecules which are in motion. Those ionized molecules forms a electric current. That alternating electric current generates a magnetic field in the Earth's surface, and this is known as the magnetotelluric field. And after repeated reflection from Earth's surface, this field becomes vertical, propagates vertical in the vertical direction. So the magnetic and electric field associated with this uh, generated due to this field are in a horizontal direction. So this horizontal electric field produces a telluric current, that is a horizontal current that flows along long horizontal lines in the subsurface.
Okay, so what is the depth of penetration in this case?
The approximate depth of penetration of magnetotelluric field is about 100 to 200 kilometer.
So, which quantity is the deciding factor here? Uh, Means the quantity which is deciding the depth of penetration in the electromagnetic method.
The frequency of the wave, the conductivity of the subsurface, and the
What is
relative
the
and the permeability of subsurface.
okay? And what is the formula for
The
skin depth?
d is equal to skin depth d is equal to root over 2 by mu sigma omega.
It is for can we apply it also for the insulators or general material?
No, for insulator it will be infinite because sigma is equal to 0.
Okay. Okay. Arghya, I think I have asked most of the question.
Thank
Thank
you.
you. Amrit, would you like to ask?
Okay, actually, I was not able to join, so I will ask from basics question. So,
Okay.
Argo, tell me the need to introduce EM method in geophysical exploration.
Uh, the EM method is used for metallic mineral exploration, and the need for it is because by resistivity method we can also get mineral explore done do mineral exploration, but in Electromagnetic method, I think we can do this by without having any contact with the ground by airborne method. And another one is in magnetotelluric method we can penetrate greater depths than other methods. These are the needs, I think.
Okay, so in electromagnetic method, what are the ranges of depth we can explore?
In magnetotelluric method, it is much more like 100 to 200 kilometer, and but in other methods, in GPR, it is very limited within 100 kilometers, and in other methods, I think within 1 to 2 kilometer.
Okay, what are different methods in electromagnetic method under this category?
There are tilt angle method, very low frequency method, audio frequency electromagnetic method, uh, ground penetrating radar, horizontal loop electromagnetic method, time domain electromagnetic method, magnetotelluric method.
Okay, you mentioned about magnetotelluric method and ground penetrating radar. Just briefly describe the basic principle of operation in this method.
Okay, in ground penetrating radar, we use short radar pulse, that is the wave in the frequency range of megahertz to gigahertz. In this frequency range, the depth penetration is limited, but the we can use the principle of reflection and refraction, so we can map the subsurface to a very low depth, like seismic method, by measuring the travel time of the reflected waves. We can get the velocity structure, and mm, we can get various properties. And in the magnetotelluric method, we measure the components of the magnetotelluric fields, like the magnet components of magnetic field and electric field, and by measuring these fields component we can get the apparent resistivity of the subsurface.
Okay, what are the variable parameter in GPR you just mentioned?
Variable parameter is the dielectric constant.
Okay, so do you know about frequency domain and time domain EM survey?
In time domain EM survey, we use pulsed primary wave. The we like a pulsed wave means we apply wave for some time and then sometime it is turned off. And in continuous wave or frequency domain survey, we use continuous EM wave. And in time domain method, we measure the secondary field when the primary field is absent. In that case, there is no overlap of primary and secondary field, and we measure the rate of decay of the secondary field. And in frequency domain method, we measure the phase difference between the primary and secondary field.
So, okay, your objective is to explore minerals, right? So, different methods. How will you plan a particular survey using these methods? Which one will be preferred first, and what should be the order?
Okay. Okay, by first of all, by tilt angle method using airborne electromagnetic survey, we can do the reconnaissance survey using tilt angle method, or uh, I think using this method. And by measuring the tilt angles, we can get the location of the conductor by covering a huge area in the reconnaissance survey. And when we get the approximate location, we can conduct the ground surveys like horizontal loop method and time domain method. From that, we can get the conductivity of the and exact location and conductivity of the body.
No, just forget about only electromagnetic. You know all the methods: gravity, magnetic, electrical, electromagnetic, and you are interested to explore a zone for mineral perspective. So, how will you plan?
Okay, for mineral perspective, at first I will do reconnaissance survey. That is survey in a large area by gravity and magnetic method, and then I can use the IP method, and electromagnetic method. I don't have clear idea actually. I am just guessing.
Okay. So, using electromagnetic method, which type of minerals we can detect?
We can detect metallic minerals, that is conducting bodies.
Using magnetic methods also, some particular minerals were there. Will it be
Yes.
same or different?
No, in magnetic method we can only detect the magnetite or the ferromagnetic bodies, ferromagnetic and ferrimagnetic. But other conducting bodies we cannot detect. So those are not same.
Okay. What are the uses of magnetotelluric method?
Uh, I think in it is mostly used in hydrocarbon exploration.
Okay, I am also done.
Thank
Thank
you.
you. सब लोग क्वेश्चन पूछ लिए क्या?
Hello.
हाँ मत प्लेस अभी
ओके, जो जो
तो
जो नहीं नहीं आया मुझे वो फिर बता दो, जो भी है अभी।
I call you for my question that you said almost all correct, and your interview is good. So I think that means I don't know anything, any improvement. But I think that you should keep it up.
And that the question you said about why light cannot be used, what will be the correct answer?
So you said almost correctly that it is frequency is very high, so its depth of penetration will be very less, and light can be used, but its depth is very low.
Okay.
Sanu, please stop the recording.
Actually, मैंने मोबाइल से ज्वाइन किया ना तो
Okay, okay, no issue, no issue. So Agya, overall interaction was with you very nice, but again a few suggestion. फर्स्ट इज दैट आपकी जो हॉबी है, सो प्रिपेयर इट वेरी थॉरोली, राइट।
Okay.
हाँ, सो एज आई आस्क कि विच मूवीज डू यू लाइक, सो यू टोल्ड कि all movies. So it is better to specify some area. Okay,
Okay.
and you should know this minimum information, which was the first movie and the directors, if you like any movie actors, actor name, director name. Okay, awards,
Okay.
and which is the highest award in this field. Okay, all
Mm-hmm.
this information you should know.
Yeah.
Um, the remaining part was very good.
Okay.
Arghya, your feedback.
और क्या इंटरेक्शन वाज गुड, आपको अच्छी नॉलेज है। बट ना कहीं कहीं आप बहुत ज्यादा इलेबोरेटिव हो रहे थे। जैसे मैंने आपसे कुछ चीजें पूछी थी कि सिर्फ टिल्ट एंगल क्या है, तो आप उसमें ना बहुत ज्यादा एक्सप्लेन कर रहे थे। तो अगर मतलब मैं यही कहूंगी, जहां अगर एक पर्टिकुलर चीज पूछी है तो आप बस वो ही चीज बोलो तो ज्यादा अच्छा है। एल्स सब कुछ अच्छा था। और आप अपनी हॉबीज पे थोड़ा सा वर्क कर सकते हो।
Okay. Yeah. Thank you.
हाँ, और को मेरा जो क्वेश्चंस था वो तो सब सही था। और वो जो मैं पूछा था कि कैसे प्लान किया जा सकता है, तो उसमें क्लियर कट आइडिया मुझे भी उतना अच्छा नहीं है। जैसे बोल रहे थे कि रिकॉग्निशंस के लिए ग्रेविटी मैग्नेटिक यूज करेंगे एक पर्टिकुलर जोन देखने के बाद, एयरबॉर्न इलेक्ट्रोमैग्नेटिक, देन डिटेल सर्वे के लिए आईपी, यही सही है मुझे भी लग रहा है।
हाँ हाँ हाँ। ओके।
बस सर, बाकी तो मैं जितना तुमको सुनता हूँ उतना और सुनने का इच्छा करता है, ये तो है। ऑल द बेस्ट।
थैंक यू।
ओके, मेरा एक क्वेश्चन है तो सबसे है, जो इलेक्ट्रोमैग्नेटिक वेव है, तो हम लोग तो फैराडेज एडी करंट जनरेट चेंजिंग मैग्नेटिक फील्ड, तो बट ये में मतलब इलेक्ट्रिक फील्ड भी चेंज होता है ना, तो उसके लिए तो रिगार्डिंग फोर्थ मैक्सवेल इक्वेशन, तो मैग्नेटिक फील्ड भी जनरेट होना चाहिए, और आई एम रॉन्ग अबाउट इट।
समझ में नहीं आया आपका क्वेश्चन।
क्वेश्चन मतलब जो मैक्सवेल फोर्थ इक्वेशन, तो चेंजिंग इलेक्ट्रिक फील्ड आल्सो प्रोड्यूस मैग्नेटिक फील्ड, सो इलेक्ट्रिक मैग्नेटिक वेव में तो इलेक्ट्रिक फील्ड भी चेंज होगी ना।
हाँ 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 हाँ, सभी सभी लॉज आई थिंक लगेंगे।
नहीं, मतलब उसके लिए रिगार्डिंग तो मैग्नेटिक फील्ड भी जनरेट होना चाहिए।
हाँ, वो जो दो है ना, एक एक में तो चेंजिंग मैग्नेटिक फील्ड इलेक्ट्रिक फील्ड जनरेट कर रहा है, और एक में चेंजिंग इलेक्ट्रिक फील्ड मैग्नेटिक फील्ड जनरेट कर रहा है। तो तो दोनों ही तो है। मैं समझ नहीं पा रहा हूँ।
तो एक्चुअली हम लोग जो मेजर कर रहे हैं ना रिसीवर में, वो तो सिर्फ मतलब एडी करंट के थ्रू मेजर कर रहे हैं,
हाँ
और जो इलेक्ट्रिक फील्ड चेंज के कारण जो मैग्नेटिक फील्ड वेरिएशन आ रही है उसको भी तो मेजर कर रहे हैं ना।
हाँ, हम जो मेजर करते हैं वो
जैसे एडी करंट तो ओनली फॉर फैराडेज लॉ,
यस।
उसमें फोर्थ इक्वेशन का कोई रोल नहीं है ना।
नहीं।
Okay. Okay, फिर so end करें session.
इसके बाद कुछ प्लान हुआ है, क्या करना है, क्या कुछ?
मतलब इलेक्ट्रोमैग्नेटिक वर्क अभी बाकी है ना, बहुत लोग हैं.
अच्छा, ठीक है।
I think we should complete it within this week now because after that
तुम्हारा
we are doing
वॉइस
magnetic.
क्लियर नहीं है।
हेलो, अभी क्लियर है क्या?
बस थोड़ा थोड़ा ब्रेक हो रहा है। बोलो, सुन दे पा रहे।
Actually, थोड़ा नेटवर्क इशू है. मैं कह रहा हूँ मतलब अगर इस हफ्ते में हम लोग न्यू क्वेश्चन से खत्म करेंगे ना, नेक्स्ट वीक मैग्नेटिक एंड देन आफ्टर
बोलो बोलो, क्या बोल रहे थे?
सुनाई नहीं देगा.
हाँ, दे रहा है थोड़ा, मतलब धीमा धीमा, लो वॉइस।
हाँ, मैं यही कह रहा था मतलब जो हमारा जो टारगेट होगा ना, तो हम विद इन दिसंबर वी विल फिनिश ऑल दिस थिंग. तो अभी तो लगभग हाफ महीने हो गया ना दिसंबर का. इट्स ऑलमोस्ट कितना है, 14 है. तो हमें नेक्स्ट 2 वीक ही बचा है, मतलब वी हैव ओनली 2 वीक लेफ्ट. तो इसमें हम एक वीक तो मतलब सब सब टॉपिक एक साथ करना पड़ेगा ना, कितने सारे मेथड है, एक प्रॉपर इंटरव्यू हाफ एन आवर में. तो इसके रिगार्डिंग आपका क्या सजेशन है ऑल ऑफ यू?
हाँ, ये तो एक्चुअली करना है क्योंकि टाइम उतना है भी नहीं। और ये जो सब मेथड एक साथ का जो प्लान था, ये भी शायद इम्प्लीमेंट करने का टाइम अभी आ रहा है। और क्या क्या एक्स्ट्रा कुछ मतलब करने का प्लान था, एक प्लान सब लोगों से सुनना पड़ेगा और क्या क्या करना है इसके बाद, ईएम के बाद।
हाँ
यही था।
हाँ, क्योंकि अभी तक टाइम और है नहीं, मतलब और 2 हफ्ते मैक्सिमम बचा है.
हाँ।
अच्छा, कॉल लेटर अभी तक दिया नहीं ना?
नहीं, अभी तक नहीं है.
ना।
तो आशुदीप वर्ड.
ये सानू पहले बस ये एम हो जाए कंप्लीट, देन आफ्टर वही करना है, मिक्सिंग ही सभी मेथड का।
बट हमें ज्यादा टाइम है नहीं ना. अब
देखो वो ठीक है बात, बट डिटेल में भी तो होना ज़रूरी है ना हर मेथड थोड़ा, जो मेन मेथड्स हैं ये।
हाँ, डिटेल्स में मतलब बट
ऑलमोस्ट हो
इसलिए
ही
कह
गए
रहा हूँ
हैं,
मतलब हाँ
ऑलमोस्ट
इस हफ्ते
हो ही
में
गए हैं।
अभी तक मैग्नेटिक बाकी है, मैग्नेटिक. ओके ठीक है, मतलब तो नेक्स्ट डे विल बी ईएम ना, इलेक्ट्रोमैग्नेटिक.
ठीक है, चलो। बाय, तो फिर अभी लेफ्ट कर रहे।
हाँ हाँ, एंड कर दी, कर
हम्म,
दीजिए।
ठीक है।